This lesson is about factoring polynomials. First thing you'll be asked to do in your homework is look for what you can take out from all three terms here. You should notice that you can take an x out of all of these terms. Do that by writing the x down in front, and then in parentheses you're going to write what's left over when you take it out. If you take an x out of this first term, you'll be left with x squared. If you take an x out of this middle term, you'll be left with plus 2x. If you take an x out of this last term, you'll be left with minus 15. Now we can't stop here. We have to look at what we have in this parentheses and see if we can break it down further. You should recognize that you can break this down into the product of two binomials. The x that we took out is going to stay out front, but then this trinomial is going to break into two parentheses here. The x squared breaks into x and x, and then we're looking for what makes negative 15 that adds up to positive 2, which is going to be positive 5 and minus 3. All of this together here is our final factored answer. Let's try that again here. Look for what you can take out from both terms. We can definitely take out a 2, and we can also take out 3 y's. So we'll be taking out 2y to the third. What's going to be left when we take that out of the first term is just y squared. What's going to be left when we take that out of the second term, and remember it's division, so you'll be left with minus 9. But again, we can't stop. We have to recognize that this is a difference of two perfect squares. Y squared breaks into y and y. The minus 9 will break into plus 3 minus 3. So we will keep the 2y to the third out front and break this into y plus 3, y minus 3. All of this together is our final factored answer. The next type of factoring you'll be asked to do looks complicated, but there's a formula. Notice whether you have a plus sign or a minus sign, and pick the correct formula. We have a plus sign, so we're going to use this one, the sum of two cubes. We have x to the third plus 64, and we need to recognize that this is the same as saying x to the third plus what to the third makes 64. In this case, it is 4 to the third power, because 4 times 4 times 4 is 64. Now, if you notice in our formula, they have a cubed and b cubed. Well, now we have an a and a b. Our a is x, our b is 4. So all we have to do is fill in the formula. The formula has, in the first parentheses, a plus b. Our a is x, our b is 4. So x plus 4. The second parentheses is a little bit more complicated. It starts with a squared. Since our a is x, we just fill in x squared. The middle term here, minus ab, well, that for us will be minus 4x. That's our a and b. And then plus b squared. Well, if our b is 4, then when we square that, it'll be plus 16. Lucky for you, you get to stop right there, put a box around it. That is your final factored answer. All you have to do is successfully fill in the formula. This type of factoring we're very familiar with. It's factoring by grouping. This is when we have 4 terms in a row, and we group them into 2 groups so we can treat them separately. I like to use brackets. Group these first 2 together, group these second 2 together. What can I take out from here and here? X squared, leaving me with x minus 3. What can I take out from here and here? Minus 16, leaving me with x minus 3 again. Get the same thing twice tells me I did it right. I'm going to bring down that x minus 3. And then in the other parentheses, we'll write what's left, which is x squared minus 16. This time we can't stop. Look at what you have left and see if you can go further. This one can go further. It's a difference of 2 perfect squares. The x minus 3 stays as it is, and this becomes x plus 4 and x minus 4. All of this together is our final factored answer. The last type of factoring here, we're going to break this down as if it was x squared, which breaks into x and x. Only instead of x squared, we have x to the fourth. So when we break this 16x to the fourth down, we'll break it into 4x squared and 4x squared. If you multiply those back together, sure enough, you would get 16x to the fourth. Similarly, the 81 is going to break down into plus 9 and minus 9. But you guessed it, we can't stop there. Look at your two parentheses and see if you can go further. This first one's done. When you have perfect squares with an addition sign, you can't go further. But two perfect squares with subtraction in the middle is the difference of squares. Our first parenthesis stays as it is. Our second one gets broken down. 4x squared is going to become 2x and 2x. And minus 9 will become plus 3 and minus 3. All of this together is our final factored answer. Similarly here, this puts it all together. You want to look first to see if there's something you can take out from all these three terms. We can definitely take out a 2, and we can also take out a p squared. That's the most we can take out. What will be left to us here is p to the 6th for our first term, plus 5p to the third power, plus 6. Can't stop with what you have in here and see if you can break it down. Just like if it was p squared, we'd break it into p and p. We can take our p to the 6th power and break that down as well. Don't forget to leave the 2p squared out front, but then break this into two parentheses. P to the 6th is going to become p to the 3rd and p to the 3rd. If you put that back together, that would be p to the 6th. Then we're looking for, just like in a quadratic, what can make positive 6 that adds up to 5. And in this case, it's going to be plus 3, plus 2. Nothing else can get broken down further, so we put a box around it, and that is our final factored answer.